I'm working with Professor Hawkins to research the physical and chemical properties of the Los Angeles pollution.
We look at organic carbon aerosols, and so these are found in our atmosphere and come from a variety of sources. So forest fires, it also comes from car emissions and from coal burning.
So we are studying essentially the impact of brown carbon aerosols and trying to get more precise data on this so that climate change predictions could be made more accurately.
So in the lab, one of the main focuses is to understand actual Los Angeles aerosol. And so we have a special inlet, which is a hole in the roof of the lab that extends to a special piece of equipment on the roof that allows us to draw air into the lab and separate out that air to the different pieces of equipment we're using to measure it.
We have a software that reads out absorbance, and it gives us a real-time series of absorbance as a function of time.
We can also send aerosol particles into our fog chamber, so we can simulate fog, because it's not that frequent that we have fog all the way out here in Claremont, but it is an important process that changes the way particles interact with light and the chemical nature of those particles.
This looks like just any other instrument in the lab, but it is a very special instrument. It gives us a time series. It tells us how the mass of organic carbon changes over time.
We can see on 15-minute time resolution what the pollution's doing in the atmosphere. And he's analyzing the data, looking for patterns to see if traffic makes a difference, to see if fireworks make a difference, what happens on the weekends, what happens at night, and how those changes relate to climate change.